This is the Digital Factory podcast. I'm John Bruner. This is the first of 3 episodes that we're bringing you from IMTS, the giant manufacturing technology conference that happens every 2 years in Chicago. It's a landmark gathering, and we've got 3 people from very different backgrounds to comment on it and talk about the future of manufacturing. If you enjoy this podcast, you'd certainly enjoy taking a look at the Digital Factory report. It came out a couple of weeks ago and covers advances in additive manufacturing, artificial intelligence, and factory automation, and it takes a look at the new business models that arise from these fields. Visit digitalfactory.xyz to download the report for free. My first guest today is Spencer Wright. He's the author of The Prepared, which is a manufacturing newsletter and podcast, and he also runs partnerships and integrations at nTopology. Spencer, it's great to see you.
Hey, John.
Spencer and I spent some time last week independently at IMTS, which is a humongous trade show in Chicago, about 150,000 people at McCormick Place, looking at all sorts of manufacturing technology, giant machine tools, giant 3D printers, robotics, assembly line setups. And with a few days of reflection behind us, thought we'd get together and talk about what we saw there and the significance of it. So, Spencer, first of all, which halls did you find yourself spending the most time in at IMTS?
So I had a super compressed trip, but I went to all of the halls, which was hard. There was a lot of very fast walking going on. I was mainly there for the additive manufacturing stuff, but also, spent a little bit of looking at CNC tools, especially on the kind of analytics and dashboard side.
Interesting. So is that, how long have you been watching the analytics and dashboard side stuff on the machine tools? That's a remarkably recent thing.
A couple of years. I mean, So I first became interested in this a few years ago when I was doing some consulting for General Electric. They were very interested in the kind of connected factory stuff. And I came across MT-Connect, which is a kind of a machine-to-machine communication protocol. I should note MT-Connect is now a sponsor of The Prepared, just like Formlabs is. I became really curious about this and kind of thinking about what information can you get off of your machine tool, and then how do you actually make that actionable? So there are a handful of companies that are working on this. The one that I spent the most time with at IMTS is called Machine Metrics. They make a dashboard with kind of customizable alerts. They also have been they've written a pretty cool series of blog posts on anomaly detection, where what you're doing is looking at all the different data that a large CNC machine tool spits out and trying to figure out before an actual major problem occurs, whether you have some chatter or some vibration or something that's happening that's going to then predict a failure.
So how about on the machine side? What did you spend most of your time looking at? Which windows did you gaze through on which machine tools?
So I mean, honestly, I ran through the machine tool section. I mean, I don't have a deep enough background in, the kind of large scale CNC machining to really know what you're looking at. And I think that one thing that's worth maybe commenting on about IMTS is it is a spectacle, right?
Yeah.
And it reminds me, it makes me wish that I had someone like David Foster Wallace to walk around with me and really just comment on the circus aspects of it. As somebody who's not, I'm not there to make a purchasing decision about a new machine tool today, it really is overwhelming, and it's more about just kind of what catches your eye as you're walking past it than it is about the actual machine's capabilities or anything like that.
Right.
So of course you spend a little time. I mean, I forget even who it was that had the basketball net. That they were machining a bunch of string out of a block of aluminum. And these things are just, they're really remarkable, toolpath generation and machine control systems. But unless you're in the business of machining basketball nets, it's really just about the spectacle and not so much about, yeah, I want to spend a minute kind of talking to this person about this thing.
Right. Well, I mean, the thing that struck me was also the scale of IMTS. This was my first time at IMTS, by the way. It's only every 2 years.
Ditto.
And so you miss one and you're out for a long time. But it's an enormous thing. It's incredibly specialized. And it speaks to kind of the fundamental structure of the manufacturing industry in general and the American manufacturing industry in particular. This is where all of these, manufacturing people and engineers from across the US and especially the Midwest come to decide which machine tools they're going to buy in the next, cycle of upgrades. So the breadth of it, and then also the depth of it, the specialization, the number of machines that are suitable for exactly one manufacturing task, that are able to lift one thing. Machines where you're paying an extra $100,000 for the machine in order to specialize in something. That really struck me. And I thought a lot about how, at a political level as well, IMTS and the kind of landscape there is what I think of when I think of American manufacturing. It's very sophisticated. It's very sort of digitally driven. It's very highly specialized. It's not at all what politicians think of when they think of American manufacturing. They think of people in coveralls swinging giant hammers.
It's Rosie the Riveter kind of stuff. Yeah.
Yeah, exactly. So seeing the specialization and, as you point out, the spectacle next to each other was really interesting, because I went to a lot of exhibits where there was some kind of really interesting, attractive machine right out front, and looked at it for a minute and then realized that, this is only intended for machining camshafts on marine engines or something like that. And it's like, this gives you a sense of what it takes to do something like machining the camshaft in a marine engine, that you need a specialized machine, and it costs $600,000, and probably you need 4 of them, and you're going to make a handful of these engines a year. Yeah.
So, I mean, it's absolutely fascinating just walking around and allowing those, the random camshaft machining centers to catch your eye. I think the 2 things that I was particularly interested in seeing from the outset were, it was a pair of large metal 3D printing machines. The first one was from a company called Velo 3D, which has been kind of whispered about for 4 or 5 years, but they finally made their kind of public debut about a month ago. And the second one was a collaboration between 3D Systems and Georg Fischer, GF Machining Solutions. I hope I'm pronouncing Georg Fischer correctly. Anyway, these 2 machines, it's to your point about specialization, they really represent very different philosophies about the future of metal additive manufacturing. On the one side, on the Velo 3D side, I mean, they have put a ton of both software and hardware engineering into trying to analyze and predict build failures in printed metal parts. And then they have a number of different compensation techniques. So they are pre-deforming parts in the design phase. And then when they print, the built-in stresses deform them back to the original intended shape. And then they also have a bunch of kind of in-process control that is meant to, make sure that the printing process isn't kind of going off on some tangent and getting away from what is originally intended.
Right. And what is Velo 3D's fundamental process?
So they use laser metal powder bed fusion. You'll hear that referred to as DMLS a lot. Right. DMLS is actually a copyrighted name by EOS, which is one of the, probably has the largest install base of any metal 3D printer in the world.
So it's fundamentally a metal SLS type process.
Yep, precisely. Yeah, you're rolling out a very thin layer of metal powder, titanium or Inconel or something similar, and then you are melting it with a laser.
Got it. And that involves a lot of heat flowing into models at different rates at different points in the model, and you got deformation all over the place. So
Precisely,
hence this control software.
Exactly. Yeah. Yeah. So, I have been tracking Velo 3D for a couple of years, and, they have a very impressive team. And they printed a couple of parts that I designed that failed on other people's printers, which I've been very impressed about. And to finally see their machine, in person, in the public, and, kind of think about what the future of the industry would be, where you're doing a lot of your manufacturing engineering in software, right? You have a piece of software that is able to take kind of an arbitrary designed part and figure out how to make it best. And then when the machine's actually making this part, it's constantly adjusting its tool paths or its power settings to make sure that the print runs successfully. Super interesting to see that in person. Now, Velo 3D also has, some additional kind of process automation stuff that happens as well. They have a removable print module, and they say that you can run prints 24 hours a day. And if a print completes in the middle of the night, the machine will automatically unload a print module, load a new print module in, and be running within 15 minutes, which is really remarkable. That's a really fast changeover time.
Yeah.
And this is something that you're seeing elsewhere in the industry. You have other companies who are focusing very heavily on this, and this collaboration between 3D Systems and GF Machining is a kind of maybe the largest example of that kind of automation happening.
So explain what's going on there with 3D Systems and GF together.
Yeah, so 3D Systems has had metal 3D printers for since like 2012, 2013, something like that. Their first printers came from an acquisition of a company called Phoenix Systems, mostly in the dental market. And then they acquired a company called Layerwise, which was from Belgium. Layerwise was mostly a service bureau, but they had built some of their own machines. And then 3D Systems built a system called the DMP 320 based on that Layerwise acquisition. DMP 320 has been out for, 2 years, something like that. But at IMTS, they announced the DMP Factory 500. So this is also a laser metal powder bed fusion printer. The build volume is a 500 millimeter cube. So it's a fairly large build volume for this type of machine. But they've teamed up with GF to add some additional automation and specifically to tie the printed parts into a subtractive post-process, right? So when you're printing metal parts, you're almost always, very rarely will you not have some machining or grinding post-process. And you'll definitely have either saw cutting or wire EDM cutting.
Yeah.
And so there's
you
this kind of
probably have to
suite
remachine the build platform as well to get it flat again.
Exactly. Precisely, yeah. So, metal 3D printing is part of this broad production work stream, and GF has a lot of experience in those downstream processes like CNC machining. So what they developed together is, I think maybe the biggest part about it is this modular build plate, where GF has some pretty cool work holding solutions where they're able to grab on to this build plate. It has a couple of registration points that make sure that it's at the right height, and then some clamp features that hold it down securely. For context, most metal 3D printers, the build plate is it's a plate of metal. It might be, let's say, a foot by a foot, and maybe it's an inch thick. It's solid titanium, right?
Right.
And it's a big piece of metal, and in each of its four corners, there's a hole that's something like a 1/2 inch in diameter, and you have a large socket heads cap screw that is bolting this piece of metal down to the machine. And this is what you're starting your print on. You're actually welding the powder to the build plate. And this build plate is bolted down. So the DMP Factory 500, this 3 Systems GF machine, it has a much more clever way of attaching the build plate to the printer, where it has these grabbers that hold it down, and then those same grabbers exist in the CNC machines that you would then bring this build platform into. So what they're saying that they can do is, again, you have a removable kind of print module. The print module slots into the printer with the build plate attached to it. And when the print is done, you'd have, ostensibly an autonomous forklift that would come over to the printer. It knows that the print has completed. It comes over, it removes the print module, it brings it over to a depowdering station where the build plate is automatically lifted out of the print module and all of the residual powder is cleaned off of it. And then you have another, again, ostensibly autonomous forklift or similar kind of cart that brings the build platform over to a large CNC machining center where then all of your post-processing is done.
And it'll actually post-process the part. It's not just about sort of cutting the part off the build platform and rinsing it and then leaving it for a human to post-process?
That's what they're saying. Now, I think that there are going to be some aspects of the post-processing that make sense to automate that way, and some aspects that it doesn't make sense to automate that way. So, I think that the part of the post-processing that I discussed with the 3 Systems folks most at IMTS was milling and drilling and tapping holes in the part. So, if you have features in your finished part that require any kind of real tolerances, then you're going to want to machine those.
Right.
And that goes for a lot of drilled stuff. It certainly goes for anything that's threaded. And then any kind of registration features, if you have a mating surface to another part of your assembly, that'll probably be machined as well. And so what they're saying is, hey, the 3 Systems software has the full 3D model of your finished part, which has all these drilled and tapped holes. And so we can actually just take the build plate out of the printer and put it into the CNC machining center, and that machining center will drill holes, tap them, machine surfaces, and then maybe at that point it's going to be unloaded by a human being who's going to break the parts off of the build platform and clean off their support structures and so on and so forth. Because there still is a lot of manual interaction in a lot of these parts, filing and deburring and that kind of thing.
Right, and especially if you're taking advantage of additive manufacturing to make low volume parts, it's unlikely that you're going to be able to set up a fully automated system for post-processing stuff.
That's right.
You're always going to have a human in
right.
there. Or for the time being, we'll always have a human in there until this stuff, advances. But what you're describing sounds a lot like what Additive Industries is doing as well, making these completely integrated, fully enclosed, school bus sized 3D printers plus machining centers plus post-processing features.
Heat treat as well, I think. Yeah.
Yeah, exactly. And there, I think a big motivation is workplace safety concerns, so that you don't have a lot of titanium powder flying around your factory and getting inhaled and getting sparked and so on. You want to keep that stuff completely enclosed. But the other thing that strikes me is that, you're describing a big 3D printer manufacturer teaming up with a machine tool company to create sort of this integrated 3D printing plus machining process. You also see a lot of the traditional machine tool makers getting into additive. So there were big additive machines at IMTS from Renishaw, from Moriseki, from Mazak, and these are companies that have really specialized in perfecting CNC mills and turning centers and all manner of CNC machine tools. And now they're basically just sort of adding additive to the lineup. Most of them are using metal powder processes, either injecting them with heat at a point or doing a powder bed kind of thing. It's interesting to see them crossing that line.
Yeah, the applications where I think that makes most sense is some kind of repair process. So for instance, the DMG Mori machine it's a machining center that then also has a directed energy deposition head on it as well. And so you can fixture an existing part that needs to be repaired in this machine, and then the DED process, the directed energy deposition, what you're essentially doing is using some kind of energy source plus jets that are blowing powder. And you're essentially TIG welding, right? In a way, right? It's very similar conceptually, at least.
Right.
And so you can build up additional metal on a part that needs to be repaired, and then come back and machine down to the finished shape and texture that the part requires. For repair applications, those make a lot of sense. They're also really great for cladding applications where you have some kind of dissimilar material on the outside of the part than you have on the inside. I think that as an outsider, it's appealing to think of additive and subtractive happening in the same machine for all manner of parts, but there end up being a lot of complications to that. One of the big ones being, for a lot of materials, if you're machining them, you really want to use coolant, and you're mixing coolant and chips with this really expensive titanium or Inconel or whatever it is powder that you want to recycle. And so figuring out how those two processes work together is more difficult than it might be when you're coming at it kind of blind.
Right. I mean, there is this appeal in, integrating an additive process with, an A-axis where you can sort of like turn the part and integrate it with a few other axes as well, so that you can add at different angles. That's not generally a feature of 3D printers. Usually all of your layers are parallel, and there are a few interesting companies that are working on layers that are not parallel, either by mounting an extruder on an industrial robot, or by doing something that looks like a 5-axis machine tool with an extruder in it. But combining these, I think, is interesting. And then in theory, you could do a lot with automating the post-processing as well, where that isn't necessarily practical if you're in a conventional machine and you have to get under the part in order to cut it, in order to separate supports. And a lot of this is, you're starting to see the path on which the really big players are thinking about post-processing and cutting down on that labor and making everything much, much easier and more practical in a manufacturing setting.
Yeah. So you were talking earlier about 3D printing processes where you're not just slicing a part in one axis. My favorite one is the clay printers, right? Where you're essentially you're making a bowl out of clay by extruding a spiral or a helix, I guess it would be. That's a great application for this very weird kind of printing, but it has an analog in the pre 3D printing world where you're rolling out a noodle of clay and then wrapping it around. That's something that we all did in elementary school. So making that jump to a kind of digitized process makes a lot of sense. But we lack similar examples in the metal world where you do have kind of non-symmetrical manufacturing methods.
In general, a thing that I was really interested in at IMTS was as I mentioned earlier, the specialization of a lot of these machines and the cost of a lot of these machines. And in what 3D printing tends to offer is some kind of improved balance between design for manufacturing effort and the manufacturing process itself. So if you're doing something very low volume, obviously you can 3D print it, and the 3D printing is expensive at the margin, but you don't have to spend ages doing a lot of DFM and revising the design so that you can make it on an inexpensive mill that can be amortized affordably. If you are doing something extremely high volume, you can afford to have a giant engineering department that's just like refining this piece and figuring out how to make it with like stamped metal or injection molding very efficiently on the margin. So looking at these machines, I'm not sure I have the answer, but it strikes me that these are very expensive machines that make sense for a handful of very specific applications in aerospace, in medical devices, in giant, highly specialized capital equipment. And there's got to be some way that these companies see these ideas moving into fields like the automotive industry, where you have much, much higher volumes. But these are also industries that are accustomed to doing just a ton of DFM and relentless refinement of their designs in order to make them manufacturable.
Yeah, that makes me think. One of the aspects of IMTS that I liked best was the kind of fluidity of different processes, and by that I mean I think in the tech press there's a tendency to put additive manufacturing in direct opposition to subtractive, right? And it's CNC or it's 3D printed, right? Mm-hmm. And walking around IMTS, you get a much more fluid feeling, right? And you see such a wide range of processes, and you also get kind of hints at the different applications that they are targeted towards, or that they have been used for in the past. And so, walking past, a metal printing machine, and then a CNC mill, and then a robotic arm, and then, something that does just metal forming. Mm-hmm. And this is not a subtractive process. It's not an additive process. It's something else. Mm-hmm. And being able to draw, being in an environment where you can kind of make different associations and rewire your brain a little bit to think about manufacturing a little bit more broadly is something I really appreciate, and that you don't always get that opportunity when you're browsing around the internet or just at home in your own shop, kind of thinking about how am I going to solve this particular problem.
Right, and you also don't get to talk to the other people who are visiting the web pages of these machine tool manufacturers to ask what they're doing with them and learning about all sorts of super specialized applications. So I'd love to move to our recurring segment, Spencer, and ask you, like I ask all of our guests, about your favorite tool. So what's your favorite tool?
So, can I give you my favorite tool of the past, 6 weeks at least?
Yeah, perfect.
So I have been on a kick of getting German hand tools.
This is a familiar kick to me.
I've had a pressing need in my life for more hand tools, and have been focusing primarily on German-made ones. And so my favorite purchase, of the summer, let's say, is a Wera Tool Check Plus, which is the kind of tool kit that I've kind of avoided for most of my career, where I just don't buy things in kits very frequently. But this thing is a combination, it's a ratchet and a screwdriver head, and then a bunch of bits. And the Germans and the Swiss as well, they do this really smart thing, which is color code metric sizes. Right. 13 millimeters, and this thing is green, and 12 is black, and 10 is yellow, and so on and so forth. And this thing, if I am ever doing work kind of in the field, this is going to be either in my pocket or in my Pelican case right next to me. It is an awesome piece of hardware. I'll note that I coupled it with a Wera torque wrench, the 7000A torque wrench. Okay. And the two of these things in concert make it possible to either do repairs or actual precision work on any fastener that I have in my shop, and most of the fasteners that I will encounter in the wild as well. And it's two tools, super compact, everything's color coded, everything's really consistent. I'm absolutely in love with this set. Amazing.
I identify with this because the most extravagant purchase, in a sense, that I've ever made was a set of PB Swiss screwdrivers. So
I've heard great things.
Swiss-made screwdrivers. They are spectacular. They cost around 50 times more than an ordinary set of screwdrivers that's 90% as good, but they're spectacular. And the best part is that in the box with the screwdrivers, I also got a PB Swiss catalog, which is this majestic expression of the Swiss approach to tools. It's, a perfect bound book, and with a satin finished cover, and pull tabs in the middle to help you, navigate to different sections of tool driver selection. So I'm into that. So we'll include a link to that driver set in the show notes that accompany this episode of the podcast. My guest today has been Spencer Wright. He's the author and proprietor of The Prepared, which is a manufacturing newsletter and podcast, and we'll link to that in the show notes as well. And he's also head of partnerships and integrations at nTopology, which makes software that helps optimize designs for manufacturing. Spencer, it's great to have you on. Thanks so much.
Thanks so much, Sean.
Be sure to listen to the next episodes in this series, which include IMTS reflections from Zach Kaplan of Inventables and Elizabeth Koprucki from the University of Chicago. And visit digitalfactory.xyz to download the Digital Factory report. For the Digital Factory podcast, I'm John Bruner.